So how do we know that a word problem will involve systems if we are not doing a 3.4 word problems involving systems sections? Usually, you know that you're probably going to have to come up with a system if the question is asking you to solve for two unknown things. So the first thing, step one in solving a word problem is to, well, duh, read it. Example 1 says, one number is 2 larger than another number. If 2 times the larger number is added to 3 times the smaller number, the result is 19. Find both numbers. When it comes to word problems, I usually first hone in on what they're actually asking us to find, and it's usually going to be the last sentence. Find both numbers. So since they're asking us, hey, find both of those numbers, I got 2 things, that's more than one variable, it will probably be a system. The first thing I like to do is define my variables. So since they're asking us to say find both numbers, I'm going to let x equals the first number and let y equals the second number. Now I usually do this step in my head, but obviously you guys can't see what's in my head, so I'll write it down for the notes. Right. Yeah. Next, what I'll do is I'll go ahead and reread the story and then try to peel out important information. Anything that's mathematical that can translate into an equation, I will. So let's start reading. One number is 2 larger than another number. Boom, there we go. So I can translate that guy into an equation. Now it says one number, 2 larger than the other number. It doesn't specify which is which, so it really doesn't matter what variable I have. So one number, let's say x, is, in math, is equal sign. 2 larger. What math operation are we doing if it's 2 larger than something? Addition. If I have if the amount of money I have is 2 larger than yours, I have $2 more. So I know it's going to be plus 2, and what am I plussing to? The other number, y plus 2. Boom, there you go. All I did was I read that sentence and I translate that into an equation. Let's keep reading. If 2 times the larger number is added to 3 times the smaller number, the result is 19. So that's clearly a mathematical sentence. If 2 times the larger number is added to 3 times the smaller, the result is 19. So I have to translate that. Now, they did specify, they did say, hey, specifically the larger number and the smaller number. So in effect, we have to know which one's the bigger and which one's the smaller. How are we supposed to do that when our numbers are variables? Read the equation that we set up before. I hope everyone can use logic and see that this says x is y plus 2. So here, this says he's the bigger number and y is the smaller. Can everyone agree that if I saw the equation x equals y plus 2, x is the bigger number? It's okay if you can't, and if you can't, please let me know so I can sort of explain it to you. Okay. Are you okay with the equation itself? So one thing you can do is just sort of like make random examples. So make a particular number, pick a number for y.
7.
Y is 7. If I plug y equals 7 into the equation, what does x equals? 9. 9 is bigger than 7. Does that always work for every y? Pick another y value. 5. If I plug in 5 for y, what do I get out for x? Is 7 bigger than 5? Yes. So you can see that in a few examples, if you just plug in random numbers, that the x will always be bigger than the y, based upon how we wrote the equation. So then all we have to do is translate the blue sentence, knowing that x is bigger by how we set it up, into an equation. Bless you. So if 2 times the larger number, we've already said x was larger, so 2 times the larger number is added to 3 times the smaller number, the result is 19. Hey, there we go. There's our 2 equations, and then you just solve it like a regular system. Okie dokie?
Yeah.
All right. One thing I don't like about this problem, though, see how the equations are not lined up? You have x equals y plus number, x plus y equals number. So before I solve it, I'd probably rearrange things. I'd probably subtract this y over. So x minus y equals 2, 2x plus 3y equals 19. And then you just go ahead and solve it like normal. For today's notes, I'm not going to solve it because I'm going to assume we've been solving systems for forever. I'll leave that as an exercise to you. But in terms of the setup, any questions? All right. Let's take a look at another example that uses just generic numbers. Say this example number 2. Now this one isn't talking about the whole number itself, but rather the digits. So the key thing about this idea is we have to know how our number system works. What does the digits 1, 2 mean? 12. What does the digits 3, 1, 5 mean? 315. Each of those numbers have a meaning. But first, let's read it. In a 2-digit number, the ones digit is 1 more than twice the tens digit. If the digits were reversed, the sum of the new number and the original would be 77. Find the original number. That's a doozy of a problem. What's going on here? So, you guys agree we have a 2-digit number? Do we know what those digits are? No. So those are my variables. I'm going to let x equals, we have an original ones digit and original tens digit. So I'll let x equals, I don't know, the original first digit, and y equals the original second digit. All right. Or first and second might sound too confusing to you. Do you guys prefer ones and tens? Use whatever terminology makes sense to you. I think I'm going to revise this after rereading the question. Since they talk about ones place, tens place, I'm going to fix this and say it's ones place and tens place. It really doesn't matter, and to prove that it doesn't matter, I'll let you decide. X, do you want him to be the ones or the tens? Ones, I hear. And then this would be the tens. All right. So let's read it. In a 2-digit number, the ones digit is 1 more than twice the tens digit. So you just go ahead and write that. The ones digit, so x, is 1 more, so that's plus 1, adding 1 more, than twice the tens digit. You guys see how all I did was translate that sentence into an equation? Right. If the digits were reversed, the sum of the new number and the original would be 77. That's very tough here. So this isn't a part of the actual setup. This is sort of like a sidebar. But when I write a number, 23, you guys know what that really says? No. We all know that 3 is in the ones place, 2 is in the tens place, right? Yeah. What this really says is you have 2 tens, and I'm adding 3 ones. That's how our number system works. So if I say, hey, if the digits were reversed, the sum of the new number and the original would be 77. Okay, sum. That's adding, right? I'm adding the new number with the old number. Let's write down the old number. Well, if x is the original ones and y's are the original tens, what's the old number? 10y's plus x ones? Do you guys agree that that would be the original number? 10 times the tens place plus 1 times your ones digit. You guys okay with how that works? Okay, I'll take your silence as a yes, because if you are utterly confused, please let me know. And then what am I doing with this? I'm adding it to the new number. So what am I doing with the new numbers? I'm just reversing the digits. So what is my new tens digit? Originally, x was my ones, y was my tens. So if I reverse the digits, what's my new tens digit? The x. And then my new ones digit is the y. And then if I add them up, they would give me 77. So there are my 2 equations. And then you just go ahead and solve them like normal. But again, I don't like how they're formatted. They're not in the right structure. So I'll go ahead and question.
Where'd you get 10 from?
Where did I get 10 from?
Yeah.
We know that this is a 2-digit number, right? And 2-digit numbers has a 1 place in the tens place. So for example, do you agree that 23 is a two-digit number? Do you agree that 3 is the ones digit and 2 is the tens digit?
Yeah.
So the reason why 23 is 23 is because it's 2 times the tens place plus 3 times the ones place. Does that make sense? So if I'm saying that I have a two-digit number and we originally said x was the original ones place and y was the original tens digit, then the original number should be 10 times the tens digit plus 1 times the ones digit, right? That's where I get the tens, because I know it's a two-digit number. Okay? Okay. And then all I'm going to do is just rewrite it so it's in the better structure. So for the yellow equation, I'm going to subtract the 2y because I like the x's and y's together. So that gives you x minus 2y equals 1. And then for the blue equation, let's just combine like terms. So that's 11y, or 11x's plus 11y's equals 77. So those are the two equations. That's the system you're solving. X minus 2y equals 1. 11x plus 11y equals 77. And then just go ahead and solve them like normal question.
Where'd you get 11?
I just combine like terms. Right? What's 10y plus 1y? 11y. What's 1x plus 10x's? 11x's. So that's where I got the 11. Right. The question was, where did I get the 20? This was an example.
Oh, okay.
That's why I put a squiggle here.
Oh.
Yeah, this is my scratch work, my sidebar. Yeah. So everything in the top right corner is not part of the problem.
Okay.
Yeah.
That's...
Mm-hmm. Okie dokie? You're going to have 2 of these digit place values problems to practice on your homework. What type of other word problems may you face? Buying and selling. So example 3, suppose a store sells black beans for 62 cents per can and pinto beans sell for 83 cents per can. If you bought 8 cans of beans for a total of $5.59, obviously this is a very old example. You're not going to find those cans that cheap. If you bought 8 cans of beans for a total of $5.59, how many cans of each type of bean did you buy? Well, what is the question asking? How many cans of each type? So those are going to be my variables. So I'm going to let x equals the number of cans of, say black beans. And let y equals the number of cans of pinto beans. Right. One hint or strategy when it comes to building an equation is if they ever give you totals, usually, thank you very much. Yeah. Usually when you set up the equations, these totals will be on one side of the equal sign. So if you read this question, do they give us any totals? I know that $5.59 is the total amount of money I bought. Any other totals? 8 cans. I bought 8 cans total. So I know that if I'm setting up my equation, it's probably going to be 5.59 equals stuff and 8 equals stuff, right? Well, think about this logically. 8 is the total number of cans. X is the number of cans of black beans. Y is the number of can of pinto beans. How do they relate to each other in terms of the number 8? If 8 is the total number of cans, X is the number of cans of black beans, Y is the number of cans of pinto beans, what is the equation that bridges everything together? Say that again? 8x plus 8y. 8x plus 8y. So 8 is the total number of cans I purchased, right? So the total number of cans times the number of cans of black beans. Logically, that doesn't make any sense because they're not. 8 is not like a number of cans I've purchased. So I wouldn't go with 8x plus 8y. Eight is the total number of cans. I'm only buying 2 beans, right? Black beans and it's x plus y. The number of cans I bought for black beans plus the number of cans I bought for the pinto beans should be the total number of cans, which is 8, right? Don't overthink these. Now, $5.59, that's the total money, right? So do you agree that whatever I put in this side of the equation has to involve money? Well, what is the only information that they give us that involves money? 62 cents per can, 83 cents per can. This 62, what is he, like, that information is connected to what type of bean? So I know that the 62 is with the black beans, and black beans are X's, so it's 62. Now, we're doing dollars, so it needs to be 0.62, because that's cents, X, and then the 83 cents is related to the pinto beans, 83Y. There you go. There's your equation that you're solving. And then you just solve the system like normal. Yep. My suggestion, you guys see how you have a whole bunch of decimals? I'm not a big decimal guy. I like whole numbers. So if your problem involves decimals, I would just go ahead, get rid of the decimals. In this case, how many place values do we have? 2. So I'd multiply by 100. Yeah, the numbers will be big, but at least you don't have decimals to worry about. So 559 equals 62x plus 83y. 8 equals x plus y. And then you just go ahead and solve it like normal. I'll leave that as an exercise to you. But in terms of the setup, any questions? Yeah. So trick, if you ever see totals, that's usually going to be one side of the equal sign, and try to link the information together. Oh, 62 cents was related to black beans, so I'll connect the 0.62 with the black beans. Right. Oh, number 4 is a classic systems question. It's a mixture problem. I would probably say, historically, kids find these the most difficult questions, which I don't think is difficult at all, but let's just read it. High school chemistry lab. James has 2 solutions. One containing 15% oil and the other containing 25% oil. How many cubic centimeters? Do you see how there's a blank here? Yeah. There needs to be a number there. Is it printed on your sheet?
Yes. How many cubic centimeters of each should he use to make 120
cubic centimeters? Okay. Of a 21%. I don't know why it got deleted on mine. All right. So how many cubic centimeters of each should he use to make 120 cubic centimeters of a 21% oil solution? So the first thing I want to do is find my variables. How many cubic centimeters of each? That's the actual question, what the question is asking. So that will be my variables. I'm going to let x equals the number of cubic centimeters of, we have 2 solutions, the 15% and the 21% or 25%. So I'll make the first one the 15% solution. And then I'm going to let y equals the number of cubic centimeters of the 25% solution. Now, when it comes to mixture problems, okay, we can use the previous hint to help us. If they give us a total, that will usually be something on its own. Do we have a total here? I have a total of 120 cubic centimeters. So that will usually be by himself. 120 equals. Do you agree that 120 represents cubic centimeters? Do I have anything written on my paper that is only cubic centimeters of stuff? Did we write down anything on our paper that says amount of cubic centimeters? X and Y. So if 120 is the total of cubic centimeters, X plus Y. Right. What's the only information that we really haven't used yet in the actual question? The percentage. We haven't used the 15%, we haven't used the 25%, we haven't used the 21%. So those are somehow going to be in play. Not a trick question. Do you agree the 15% relates to the 15% solution? Yeah, I mean, like, no duh. What variable relates to the 15% solution? So do you agree that the 15% should be attached to the x? Yes. So my second equation, the 15% as a decimal, should be attached to the x. The 25% as a decimal should be attached to the y. And what does he equal? That's the question. 21, right? It should equal 21%. But here's the problem. Do you guys agree that the 0.15 is a percentage? What did x stand for in our problem? The cubic centimeters. So on the right side of the equation, do you agree we have percent times cubic centimeters plus percent times cubic centimeters. In order for this to be a true equation, shouldn't he equal percent times cubic centimeters? We only have a percent. We're missing a cubic centimeters. 120. That is the second equation of this problem. There. And then, of course, I'd go ahead and clean them up a bit. 120 equals x plus y. I'd break out my calculator. 21% of 120. 0.21 times 120 is 25.2 equals 0.15 y or x plus 0.25 y. And then you just go ahead and solve that system. Again, you can solve it using decimal numbers. That's A-okay with you. But if you don't like decimals, you can go ahead and move the decimal place. So we have 2 decimal places, so that's 100. So the system I would solve is 120 equals x plus y, and 2520 equals 15x plus 25y, right? And then you just solve him. Solving these problems is half the battle. If you can solve word problems, I would say you're like 80% of the way there. The other 20% is actually doing the algebra. But if I had students that could read a word problem and come up with the correct equation, I'd give like most of the points. Another classic system word problem involves speed. Usually flying a plane, rowing a boat, walking on those moving walkways at the airport. Usually you'll be doing a systems problem. And the idea is, if you haven't taken physics, that distance equals rate times time. Right. Also, the other idea, if you go with the flow, you add speeds. If you go against the flow, you subtract. Right. And that should be sort of common sense. Can you guys imagine, yes, you guys do, every single day, walking down the stairs, right? There's a big traffic jam. If everyone was walking in the same direction, things are okay. You just walk naturally, right? Imagine you were at the bottom of the stairs, everyone was walking down, and you had to walk up. Would you be walking up really fast? No, you're going against the flow, they're going to slow you down. So that's sort of the idea with speeds. If you go with the flow of something, you tend to speed up. If you go against the flow of something, you tend to slow down. And you speed up by adding, you slow down by subtracting. So let's read this question. In a small rowboat, it took Alice 6 hours to go 6 miles upstream, but she was able to return to her starting point in only 45 minutes. Assuming her rowing speed was constant, what was the speed of the current? The idea is when you row upstream, you're fighting against the water, so the water will slow you down. When you go downstream, the water is pushing you forward, you go faster. So let's just go ahead and read the information and see what variables they give us. 6 hours. Obviously, that's time, right? That I hope I don't have to explain that. 6 miles. What is that? Distance. 45 minutes. What's that? Time. They give us 2 times. That's weird. Oh, she has 2 trips. Up speed or upriver and then downriver. So we'll probably have 2 equations. Let's do the upriver equation. So remember, the equation is distance equals rate times time. Upriver, what distance did she travel? 6 miles equals her rate. We don't know what her rate is, right? But we do know that she has a rate and the water has a rate. So let's define the variables. Let's let x equals Alice's speed, and let's let y equals the water speed. Or in other words, the current. Well, since she's going up speed, up river, the water is slowing her down. So I want to take Alice's speed and subtract the water speed because it's slowing her down. How long did it take her to travel 6 hours. Let's go downriver. Now, in the time that she rose up water, we can assume there's no earthquakes. We can assume that the tectonic plates aren't shifting. We can assume that, the river doesn't magically lengthen. So when she goes back down the river, what distance is she traveling? The same 6 miles. But her speed, when she's going downriver, she's going faster, the water will add to her speed. And then time, how long did it take her?
45 minutes.
A common mistake students make is they would put a 45 here.
45?
It's not going to be 0.45 either. You have to make sure your units are consistent. So if this 6 is in hours, we need to convert 45 minutes into an hour. So how many minutes are there to an hour? 60. So it's 45 over 60 hours. Yep.
Oh, how many equations? Fractions?
I would use a decimal. 45 divided by 60 is 0.75.
Wait, can't we just turn hours into minutes?
Another alternative is you could leave this as 45 and convert the 6 hours into minutes. That's another possibility. That would be 360. Tends to be a big number, but whatever way you use is totally fine by you. I'm going to keep it in hours because when it comes to speed, we typically like miles per hour. All right. There you go. There's your setup. And then you just solve it like normal. Again, I don't like the way it's put. I want to convert it back to our original format. So I'll go ahead and distribute everything in. That gives us 6 equals 6x minus 6y. This gives me 6 equals 0.75x plus 0.75y. And then go ahead and solve that system. If you don't like the decimals, of course, multiply by 100. Okie dokie? Yeah. So when it comes to speed problems, an airplane in the air, a boat in the water, the idea is distance equals rate times time. And the idea is if you go with the flow, add the speeds. If you go against the flow, subtract the speeds. Last but not least, you will have word problems that have 3 variables, 3 equations, the stuff that we did yesterday. It's not anything new or different. It's the same concept except longer. So let's read this. A study of frogs at a national park revealed to be a total population of about 5,950. There are 3 types of frogs in the park: narrow mouth, spade-foots, and midwife toads. If there are 3 times as many narrow-mouthed frogs as spade-foots and 1.5 times as many spade-foots as midwife toads, how many frogs of each type are there in the park? Lots of information to parse. First thing I'm going to do is define my variables. How many types of frogs we have? We have 3 variables. We can use x, y, z, n for narrowed, s for spade, m for midwife. Use whatever variables you want. I'm a boring person. I'll use x, y, z. So x is the number of narrowed mouth frogs. Y is the number of spade-foots. And Z is the number of midwife toads. Right. So first thing I do is I read the story, and if there are any totals, they're usually going to be off on its own on an equation. A study of frogs, National Park revealed a total population of, 5,950. Total population. So that will probably be an equation on its own. 5,950 equals 5,950 is the total population of frogs. Do I have anything on my paper that talks about the number of frogs? X, Y, Z. So you add them up. That's one equation. One down, 2 to go. There are 3 types of frogs. We got that. If there are 3 times as many narrowed mouth frogs as spade-toed frogs, that's going to be tough for some students. So there are 2 more of this. There's 5 less than that. Those sentences are easy to write. But when it comes to multiplication, I would put money that 99% of my students always gets confused. This is the way you do it. The first thing you do, if they ever compare different quantities using multiplication, figure out what they're comparing. There are 3 times as many narrow-mouthed frogs as spadefoots. We're comparing narrow mouths to spadefoots, yes? So that's x's and y's. I'm going to write x equals y. That's wrong, that's false, but I'm going to write them down. Now read that story. There are 3 times as many narrow-mouthed frogs as spadefoots. So which should be a bigger number, narrow mouths or spadefoots? There should be narrow mouth, that should be the bigger number, right? So which is x. So do you agree? The equation says big equals small, right? Which is a false statement because big should not equal small. They should be equal, right? So do you agree that blue sentence there, the math thing that's going on is times 3? If I want to make this to be a true equation, right now it's big equals small, which is wrong, it's false. Do you agree I need to make the smaller number bigger? That tells me I need to put the times 3 with the y. That is the equation of the blue sentence. There are 3 times as many narrow-mouthed frogs as spadefoots. This is the equation that it says. A common mistake students make is, 3 times narrow mouths is x, that's 3x equals y. That is wrong. If that confuses you, just start with the variables equal to each other, ask yourself, which side is big, which side is small, and then try to balance the equation. Because they're supposed to be equal. Yeah. We'll do the same thing with the orange sentence. There's 1 time as many spadefoot frogs as midwife toads. Do you guys agree we're comparing y's with z's? So I'll do y equals z, which is not a true statement, but we're going to fix them. 1.5 times as many spadefoots as midwife toads. Spadefoots, midwives, which one's the bigger number? Spades, which are y's. So we have big, small. If this is still supposed to be equal, I need to make the smaller into a bigger number. 1.5 goes on the z. That is your third equation. Because we have 1 equation here, 2 equations, 3 equations. Right. Now, of course, I want to set it all up. I don't want this to be all I want it to be lined up. So the system that we're solving would be 5950 equals x plus y plus z. For the blue equation, let's go ahead and subtract the 3y over. So we have 0 equals x minus 3y. And for the orange or green, whatever that color is, that equation, let's subtract the y over. So we have 0 equals negative y plus 1.5z. That should be the system that you're solving. All right. Okay. I spent a lot of time on showing you different types of word problems and how to set them up because, again, when it comes to word problems, that's more than half the battle. Now, on the practice, I do actually want you to go the full step and solve it completely, but for the notes, I just showed you the setup. Once you have the setup, I'm going to assume by now we're good at solving systems.